Hey guys, welcome back to Tech Tuesday, and today we're going to have a little discussion about King of the Hammers 2026. Now, if you watched the race this year, you know just how ridiculous this year's course was. Out of all of the competitors, I think it was around 90 cars that crossed the start line. Only 2 finished, one of which was Josh Bleiler with a full hydro system running our RDT pump setup. So congratulations to Josh and the Big B Motorsports team. But that means that we had somewhere around 90 cars that also DNF'd. And of the cars that DNF'd this year, it seems like steering was right up there at the top of the list. Between both the Everyman Challenge and the 4400 race, steering problems with primarily steering cylinders, if it was a full hydro truck, or steering racks with the IFS cars, were incredibly prevalent. So we're going to talk a little bit about why. Now, as cars have been evolving and getting bigger and heavier and faster, running bigger tires, now guys are going to be hitting rocks at higher speeds, which means that there's more impact and more shock load and pressure spikes that steering systems are seeing. Now, there were a number of different root causes for some of the failures that we saw this year, some of which I believe were pressure spike related, some of which were not. So for instance, if you were watching Paul Wolfe on lap 3, leading the race until his steering cylinder failed, that one wasn't actually a hydraulic failure, it was a mechanical issue because he had dropped off of a ledge with his wheels at full lock, and when he landed, he didn't have steering stops on the knuckles, so the entire weight of the vehicle was then pushed onto the hydraulic cylinder gland and caused the retaining ring to fail, and that whole thing spit out. So that was what ended his race. But there were some other failures that we saw this year that I believe were pressure spike related. Some other manufacturers' hydraulic cylinders are known to be a little bit more prone to issues with piston seal failures, mainly due to the cylinder tubes would balloon out under heavy pressure spikes. So one of the things that I wanted to talk today about is one of these guys here. This is what's called a cross-port relief valve. It might also be referred to as a crossover relief, a cushion valve, a shock valve. They go by a number of different names, but essentially what it is it's a 4-port manifold that goes in between your control valve and your steering cylinder. So if you're running full hydro, this would go between the cylinder and the orbital valve. If you're running an IFS truck with a steering rack, this would go between the rack and servo. And it has 4 ports, so on each end there's going to be 2 ports. We have C1 and C2, and then directly across we have V1 and V2. So the way that this would get installed on the car is you would take your left and right hoses going between the control valve to the cylinder, you'd basically cut them in half, and you'd run one in through the V port and the other end out through the corresponding C port, and vice versa for the opposing turning hose. So for instance, you'd take your right turn hose, run it into V1 and out C1, and then your left turn hose run into V2 and out C2. Okay, so what these 2 cartridges are here, these are very fast acting pressure relief valve cartridges. They are what's called a differential area pressure relief valve. Now, in the world of hydraulics, there are a number of different types of pressure relief valves that can be used. The most common are going to be either a direct acting or a pilot operated pressure relief valve. And each one has its pros and cons. Just like any type of valve decision selection process, these differential area valves have their own pros and cons. But one of the pros with these is that they are extremely fast acting. So we have to keep in mind that, for instance, in a normal trophy truck system, we are using for our main relief valve in the system, we use a direct acting pressure relief valve, and that valve is going to take about 5 to 10 milliseconds to respond to a pressure spike in the system before it overcomes the spring load that's preloaded on the valve spool, opens up and begins relieving pressure. And in that 5 to 10 seconds, you might have a pressure spike that reaches 2 to 3 times what that relief valve pressure setting is, and it's really just the response time that's allowing such high pressure spikes to occur. So with these differential area pressure relief valves, the way that they work, they have a much lower spring rate that's preloaded on the valve spools, and it allows them to respond much quicker in about typically 2 milliseconds. And we would set these at a much higher pressure as well. So for instance, in a normal trophy truck or Ultra4 setup, we might have our main relief set around 1600 to 1650 PSI. And we would take this valve, we would set both of these relief cartridges at about 2300. So then when you do clip a rock or you have a major pressure spike in the system, now you're relieving at 2300 PSI very quickly, directly from the left to right side or from the right to left side. And you're relieving that pressure spike all right there at the cylinder without having to send all of that pressure back up through the control valve, back up to the pump and up to the main pressure relief. So there's, it greatly reduces the pressure spike load and the potential damage that we see on steering cylinders and on steering racks and on servo valves. For the trucks that we've had running them for the past few years, we've seen a major reduction in seal failures and other hydraulic related root causes and causes of damage. Now, I've spoken to many different builders, many different race teams, and there's always this very common misconception that drivers don't want to add these to their system because they're afraid that it's going to result in extra feedback in the steering wheel. They don't want to clip a rock and have the wheel rip out of their hands. You know, we've seen drivers that have damaged, injured their thumbs, injured their wrists, hurt their hands because of steering wheel kickback, and so obviously we want to avoid that at all costs. But the misconception that this valve is going to add feedback to the steering wheel is really not, it's not an issue. Because of the fact that these are opening only once you reach about 2300 PSI, and they're not immediately just going to drop the pressure in the system, which would cause feedback. They're basically just clipping the pressures in excess of 2300 PSI. So at the point that these valves are open, you still have 2300 PSI in the hydraulic cylinder fighting whatever external impact is pushing on your steering system and causing that pressure spike in the first place. So we have a number of drivers in Ultra4 and Trophy Truck that run these valves on their vehicles, and none of them ever actually feel that it's there. It's hydraulically invisible to the system because it's set at such a high pressure. And it really has gone a long way at reducing those failures. Now, we know that Paul's was a mechanical failure. There are at least 2 cylinders I'm aware of that had piston seal failures, and they are cylinders of a specific type that's sort of known to have problems with the cylinder wall ballooning out and causing piston seal problems. So I believe that something like this can really reduce the risk of experiencing that type of failure. There were some other cylinders that we saw, multiple instances of gland end seal failures this year. I really don't believe that any of those were related to physically bending the cylinder rods or anything of that nature. And the fact that so many of them failed, my speculation, and this is purely speculation, is that those were more related to manufacturing defects, either dimensions being out of tolerance or not designed properly for the seals that they were using to begin with. But until I actually get my hands on one, that's really just speculation. So we did see, like I said, a number of different root causes. They were not all pressure spike related that were the reasons for failures this year at Hammers, but something like this I do believe would go a long way at improving the reliability on these steering systems. And knowing that these cars, the Ultra4s, the Trophy Trucks, are only going to be getting faster and faster as the rest of the vehicles continue to evolve as well. We see shock technology constantly improving. We see engines getting more power, drivetrains that can handle more horsepower. So it means that just as time goes on, we have to design the steering systems to grow with and to evolve with all of these other vehicle systems, because otherwise, things like failed steering cylinders are what's going to take a car out of a race, and somebody that maybe has a cross-port relief valve might not have the same issue, and if they get to the finish line, that all you have to do is reach the finish line and you're on the podium if it's a year like this past year. So anyway, if you have any questions about cross-port relief valves, we keep these in stock. We will preset them to whatever pressure you need, but we typically will do a standard 2300 PSI that covers most trophy truck and Ultra4 applications. Fun fact, this is the exact model actually that is used on the Monster Jam trucks. So Gravedigger and all of the other monster trucks that are 10 to 12,000 pounds landing from 30, 40 feet in the air onto flat ground. These valves prevent them from ballooning out their cylinders and having piston seal failures. So it works for monster trucks. It's been proven to work in trophy trucks and Ultra4s. So it's something that I believe in, and you know what? We're just gonna keep evolving and pushing the sport, and this is part of it. So thanks for watching. Come on up. Oh, do you like cross-port relief valves? Yeah? No, you like bones.